Welcome Physics 240 to the tutorial on how to do number 20 from the Winter 2013 exam. So I got this problem wrong because I was running out of time on the exam. Pretty much just ended up guessing. I guessed something that I thought would be much bigger than the original capacitance if there's just air between the plates. It turned out that the dielectric didn't end up adding that much capacitance. So the first thing you gotta do is draw this as a system of capacitors. You have two that are going to be added in series first, and then you have another one that you're going to have to add in parallel. Because what you're going to do is just scoot over this guy to the edge of the plate, and it's going to act exactly the same. That way you got all your air in one place, is C1, and then you add the air plus this little hockey disc of dielectric with some more air. So relevant concepts are, you better know the formula for capacitance by now, and how to add capacitance in series and how to add in parallel. So you find the total area between the plates is going to be pi times 0.6 squared. Don't forget to read the problem. You're going to have a diameter of 1.2 meters, which actually means you have a radius of 0.6 meters. If you don't read that, you're going to have a bad time. I can guarantee it. So therefore, the area of the dielectric is going to be pi times 0.3 meters. They give in the problem it has a radius of, or diameter of 0.6, so half that is 0.3. And then the area of the remaining air is going to be the total area minus the area of the dielectric. That's pretty important to know. And so to calculate the capacitance of just this half with air over here, remember we slid over the dielectric, it's just going to be epsilon naught A1 over 0.006 meters. They gave you the separation is 6 millimeters, and so that's not too hard. C2 is going to be your dielectric constant times epsilon naught times the area of that this dielectric takes up over 0.003 meters, because they give you that it has a thickness of 3 millimeters. And C3 is going to be epsilon naught area of the dielectric, because it's like the air right beneath it that we're calculating. Divided by 0.003 meters. That's the other half of the distance, from here to here. And that's going to give you C2 and C3. And then you're going to go back up to this formula over here and calculate the equivalent for C2 and C3 in series. And it's going to be their inverses add together and then taken to the negative first power. And then what you're going to do is you're going to add these two together now that you have them redrawn, so it's more like this. You've got two capacitors and now they're in parallel instead of being in series. That's a pretty bad drawing, but you get the picture. And you're just going to add them together so that C1 plus C2 is equal to the equivalent capacitance. And you find that the equivalent capacitance is going to be 1.8 times 10 to the negative 9th farads. Thank you very much, and I hope this tutorial helped.